Welcome to Postgres Build 2020. I am Dimitri Fontaine and we're going to talk about PostgreSQL architectures in production. Before we get there, I wanted to let you know that I've written a book. It's named The Art of PostgreSQL, and the book is intended at application developers who are using PostgreSQL in the context of their application, and they want to do maybe you want to do more with the SQL and understand how much you can go with PostgreSQL and its SQL support and more than that. So you can use as part of this conference benefits this coupon code that I've made just for you guys with a 20% discount. So folks, have a look if you want to. Now let's go to PostgreSQL architectures in production. What do we mean when we say that title? So what I like to do is go over each single word of the phrase PostgreSQL architecture in production. First, PostgreSQL, of course, the world's most advanced open source relational database. What does it mean? Many things. What does it mean for your application? That's more important. Your application might be written in Java, Python with Django, Ruby on Rails, PHP, or Go, or another technology. Why are you using PostgreSQL within your application stack? Some people would say to solve the problem of storage. Because you have things in memory, you want to store them. So for storage, you use Postgres. Well, I'm not sure. If you want to do storage, you can write to a file and have that file stored for you on maybe Azure Blob Storage or maybe S3 or something else. We use PostgreSQL because it implements all that is needed for concurrency. You need in your application to serve multiple users at the same time, and so you need to do multiple transactions with inserts, updates, deletes, all concurrently. And PostgreSQL is there to handle concurrency access to the data, a single source of data with concurrent access. That's why we use PostgreSQL. What is a PostgreSQL architecture? So PostgreSQL fits in a software system where you have the code you've written in your application, Java, Python, Ruby, Go, PHP, any technology you use. You have code written in that technology and served on an application server. And then when you need to access concurrently to the same dataset, there is PostgreSQL behind it. And having several components that talk to each other, that is an architecture, that is a software architecture. And the architecture we are going to focus on today is the PostgreSQL part, obviously. And what does it mean to have a PostgreSQL architecture for your application needs? And one aspect of it that I want to focus on today is what happens in production. What does it mean to be in production? In this image on the slide, you can see people handling a sport event. So some people are having a sport event in a stadium, and some other people are watching the event live from their own home. In the middle, in between them, people are working on the console to video stream the content that is captured live to the home of the watchers. That's a way to do production. When we are running, let's say, a web application in production, we are lucky enough that we don't need to actually be at the console for our users to be able to enjoy our application online. So our idea of a production is still that people are using it now live. The difference is we don't want to be there. And we have the abilities not to be there. And while we are not there, we still want the application to be available to the users. And if you're deploying code in between releases, new releases of your code and new versions of it, the code is static, it's stable, it's not changing. So it's pretty easy to maintain high availability, or availability at least to begin with, for the code. For the database, that's different. You need the availability of the service. You need to be able to connect to Postgres in a meaningful way and then have access to all the data. So you need availability of the service and the data when you have PostgreSQL in production, and no one sitting at the console to make sure that everything is right. The service needs itself to be available at all time. And when we have availability, we can also talk about high availability, what it is. We talk about high availability when we measure availability in terms of how much time a year is the service not available. And you decrease from 100% if it's always available, always on, it's 100%, right? And if anything happens and the connection is not able to access your service, your PostgreSQL instances, then you lose some percentage of availability on the year. And high availability, there is a threshold that you need to define depending on your SLAs and your application needs and your customers and users. But let's say it's 99.99% of availability a year. The ballpark I try to remember is usually the high availability threshold means that you are allowed around 5 minutes of downtime a year. So if you install a kernel security upgrade and the fact that you need to reboot your server is going to take you at least 5 minutes, well then maybe you're not highly available anymore. That's it. And maybe something else needs to happen, because rather than the kernel security upgrade that was planned for, maybe one node, either physical in your own data center, or maybe a VM in your data center, or maybe a VM online in the cloud, maybe one of those nodes is down, not available anymore. What happens then? If all you have to run PostgreSQL is a single node, it's easy to figure it out. What happens is you lose availability, and you might have lost data too. So for high availability, we need to maintain the service, even in the case of a faulty hardware or a missing VM. And so we want to automate the failover so that we don't have, like in the picture before, to actually go on the console to be able for our users to use our service. And we need to do that to implement automated failover in a way, that you don't lose data. We need to maintain both the service and the data. And to maintain the data, we need online backups, consistent backups, and we need disaster recovery. And we're going to see about streaming replication to implement all of that. The classic PostgreSQL architecture looks like this. If you want to have HA with Postgres, you need 3 nodes, basically the primary and 2 standby nodes, because what we want is to ensure that we still have data even if we lose any one node. If you lose one standby, you need to be able to say that you still have an extra copy of the data. The data is not just only on the primary, it needs to be somewhere else to maintain availability of the data, whatever happens. So we need 3 nodes so that we can lose a standby and still have a copy of the data that is extra to the primary. So if you want to have a good trade-off of availability of the service and the data with Postgres, 3 nodes are needed, 1 primary, 2 standbys. And also in case another kind of error happens in production, typically, a delete with a were close, or maybe a truncate, but it was not on the server for development or staging, it was on the server for production this time. This is something that happens a lot. It happened to me and my teams when I was working as a DBA, and then I saw that happening when I was a consultant, and I still see that happening sometimes. So sometimes truncate or drop table or something is going to happen in production that was not planned for. It was not part of the schedule, but it did happen still. So what's next? Next is point-in-time recovery, disaster recovery. And that is only possible to implement if you have an archive. We'll get back to the archiving later. So now if you have an architecture for PostgreSQL in production that looks like the following with the primary 2 standbys, archiving, etc., do you want or do you need to go to the console when something wrong happens or something unexpected happens, or do you not? So if you want to avoid that and maintain a very high availability, so if you have less than 5 minutes a year to react, maybe you want to automate everything. So how do we implement Postgres failover, and how do we automate Postgres failover in order to achieve high availability? That's the talk today. PostgreSQL implements almost all you need for failover. Included in Postgres is streaming replication. It actually is streaming. So if you update 1,000,000 rows on your primary instance of Postgres while the update is happening for every row one after another. Postgres is going to record the binary changes that are made in a system called the WAL, the write ahead log. This system is streamed to the secondary in a way that during the 1 million rows update, every row update is going to be streamed concurrently to the standby servers. And when the transaction commits, it's only the transaction commit message that needs to be synced on the standby, because the standby hopefully already received the 1 million rows updates in the WAL stream. When we say sync in streaming replication, what we mean is something different from what the word would usually mean. Sync, you would expect that two events are going to happen at the same time at different places. Well, that's not physically possible, I'm sorry. Speed of light is not infinite. So if you have two events that you want to happen at different places, they're going to happen in different times. Sync doesn't mean we have a magic wand to make it happen at the same time. Sync means we're going to pretend they happened at the same time by waiting until it happened on the secondary. And sync means I am happy to wait until it did happen. What's in PostgreSQL, included in Postgres, that you don't have in many other technologies, is the ability to say that every transaction has a way to choose if it's going to be sync or not sync, async, usually asynchronous. So given a transaction, it's going to have the ability to choose between sync and async. One way to do that, as on the slide, is to use alter role, so that you have a VIP role that is happy to wait because it's a VIP and everything it does is important enough so that it's going to wait. And you can have other kinds of roles, and you can have a default setting in alter database. So that's one way to do it. Included in Postgres also is online streaming changes. It's possible to do a concurrent, consistent backup online. So while the application is accepting inserts and deletes and update, and PostgreSQL is doing that concurrently for the application, you can also do a pgbash backup to prime another standby or just to make an archive. It's possible also to use tools just such as pgrewind. In the case when there is a failover happening, you have a new primary. A was the primary, now B is the primary, and C needs to reconnect its streaming connection from A to B. So it's going to disconnect from A with a restart and connect to B now. And to make everything right again, it might need to do a pgrewind. That's included in Postgres. What's included also is if you need to fetch some WAL bits that you missed, you can fetch it either from a primary, that's classic replication, or from another standby, and that's cascading replication if you connect to a standby. And that allows to implement fast forward, right? So that's included in Postgres. And also in Postgres, the standby is a hot standby, because when a standby is promoted, if read-only traffic is happening, the traffic is not interrupted by the promotion of the standby. The standby is promoted online. Everything that was happening just continues, and now it's not a standby anymore, it's a primary. Included in Postgres also is a limited aspect of point-in-time recovery. We insist on the recovery side of things because to be able to implement point-in-time recovery, you need an archiving system. But archiving is provided separately. You need to find a system to implement archiving. Usually, people will use tools that are part of the PostgreSQL ecosystem at large, such as pgbackrest or Wally or WALG or maybe Barman. And please use those existing software rather than implement your own facility, because it's full of traps and you want to avoid traps. Included in Postgres for HA is also client-side HA. PostgreSQL supports multi-host connection strings. It means that when there is a failover, your client is still going to lose its connection, right? And when your connection is lost at the client side, as an application developer, you need to reconnect. There is no magic around it. You lose the connection, you connect again. The thing that is magic and provided for by Postgres is that you have a single connection string with multiple hosts in there, and a way that each time you connect, you magically connect to the current primary and not to another server. So please use the multi-host connection string and make sure that your application connects again when the connection is lost because a failover did happen. What's not included in Postgres though, it's the archiving itself. Archiving in Postgres core is a concept with an archive command and other things around it. But the concept is not implemented in Postgres. So you have to implement it yourself. Again, please consider using pre-existing software offered by the community as open source. And I named before a list of software. So use something that exists already. But what I want to stress, and we'll get back to that, is archiving is not part of Postgres, and we will see what it means later. What is not included in Postgres also is what some other systems call online membership changes. Membership is the fact that you know of a list of servers that are participating into the service and you maintain the service around that. PostgreSQL doesn't have a list of standby that are supposed to be connected at any point in time, and you cannot make the difference between what's currently connected and what's not there at the moment. There is the notion of a replication slot that allows you to take care of some of the details around that, but it's not the same thing as saying, I know a list of servers that are supposed to be there, but currently they're not. And some gossip protocol and some consensus protocols, such as Paxos or maybe Raft, can be used to implement online membership changes. PostgreSQL doesn't do that. PostgreSQL doesn't have, at the moment, the idea that the role of a node in terms of being a primary or a standby, a secondary, the idea of a role is dynamic. It will change while live, because something might happen to the primary that causes a failover. And when a failover happens, the primary is no longer a primary. The configuration just changed. The role of the server is not the same anymore. And that idea is not included in Postgres. What's not included in Postgres also is configuration management. Say you need to change postgresql.conf, maybe for performance reasons, maybe for something else. You do that on the primary and the failover happens. Well, if you didn't take care of shipping the configuration changes to the secondary too, the secondary is going to be promoted and it's a new primary now with the old setup. So that might be a problem for you. Also with pghba.conf, if you have a new application node you deploy in production, you need to change hba.conf to make it granted to connect to Postgres. When you do that, remember to do it on every PostgreSQL node on your system. If you do that only on the primary, as soon as there is a failover, then your new node for the application service is going to be unable to connect. So that's not included in Postgres. Same with extension management. Extension management in Postgres is a two layers story. There is the operating system part and there is the PostgreSQL catalogs part. If you install, say, PostGIS, you need to have the package ready on the operating system before you can do create extension PostGIS. But when you do create extension PostGIS, the changes that happen on the catalog of Postgres, the SQL visible changes, are going to make it through the wall and the streaming replication to the standby nodes. So you need to make sure yourself that you also installed, the operating system level package for the extension, because otherwise when you fail over to the standby, then all the queries that are using PostGIS are going to fail for the lack of postgis.so in case you missed the deployment of the extension on all the servers. So that's not included in Postgres. Extension management for HA, it's not included. And also, one very common way to lose some of the nines in your HA setup is with PostgreSQL upgrades, because either minor or major upgrades, both of them need a restart of Postgres. And scheduling the restarts of Postgres in a smart way to avoid downtime for the application, well, it's not included in Postgres. So with that in mind, I wanted to show you a system that I have been working on to implement automated failover. The system name is pgauto failover, and the basic architecture looks like this. With one primary and one standby, as we mentioned before over and over again in this presentation, you may not have HA of both the service and the data with a single secondary node. In pgauto failover, a standby node is named a secondary when it's ready to failover, to accept a failover, when it's a failover candidate. When the primary can be removed and replaced by a standby, we call the standby a secondary. So if you have only one secondary, you don't have HA, but already you have a failover system that you can use, where if you lose the primary, then you can use the secondary instead. So maybe that's good enough for some applications, and maybe it's a good starting point. And to get started with that, here is how you do it. Create the monitor, the first Postgres instance, and then the second. pgauto-ctl create Postgres allows the monitor to decide if the node is going to be a primary or a secondary. And remember, if you're using pgauto failover, it's because the role of primary secondary that will change over time automatically. So you don't create a primary node, you create a node that happens to be currently a primary, and that will change. Now, let's say you want to switch to a model, an architecture where you have both a primary and also two standby nodes. So you have 3 nodes total. And then you can have HA because you have 2 standbys, and if you lose a standby, you still have a copy of the data that is not just on the primary. To implement that with pgauto-ctl, given what we did before, all we have to do is create a new node. Again, create Postgres is all you need to remember. So it's exactly the same command line as before, copy paste, and then you have a third node running, and the monitor is going to sort it out. And sometimes you want a third node. So either that way, so now you have 3 standby nodes, and that's how you do it. Again, same command. Or more often, it's called the disaster recovery architecture, where the third node is either, if you're on-prem, in its own data center somewhere else, or if you're on the cloud, in a different availability zone. So you have a primary and 2 standbys in the main availability zone, and maybe you have another secondary far away for the worst case, disaster recovery. If there is a disaster that happens on the primary zone, maybe you still want an extra copy of the data. And for this copy of the data, maybe you want to have a different set of settings for the replication. So this node is not participating into the replication quorum, and it's not a candidate for failover. So you make that happen with pgauto failover by simply saying replication quorum false and candidate priority 0, either when you create the node, if you think about it at the creation time, you can do that already. And if you forgot to do it, or maybe if the node has moved from one data center to another, or from one availability zone to another, well, maybe you want to change the parameters online, and then you can do that with a pgauto-ctl set node dynamically while the system is live. You can do that. So included in pgauto failover is the handling of streaming replication with replication slot maintained both on the primary and the secondary nodes, so that anytime the topology changes, the primary is failed over to a new node, well then every node can reconnect and everything goes fine because we maintain replication slots for everybody from the get-go. That's how you do it with Postgres, and it's included in pgauto failover. We even include easy to set up SSL, either self-signed or fully signed certificates. And you can change your mind online, of course, again. So you can install certificates as you go while the nodes are online. All the settings in pgauto failover, they may change online. What we include in pgauto failover is a registration of all the nodes so that we have membership and we have network topology and we know about things. And we implement with that the idea that nodes have a dynamic role. Roles are dynamic. That's part of the membership. If a node is found unavailable, no node is able to connect to it, then it's demoted. If it was the primary, well then another primary is elected. If it was a secondary, well, then it's not a secondary anymore. It's a catching up standby instead. And that's all implemented in pgauto failover, and it responds dynamically to what happens on the network. You also have commands shown in the slide to show the current multi-host URI and the current state of the cluster and the formation settings, of course. And all of that can change at any time. And with membership changes, we can also do settings changes, like we saw before, changing the priority of a node, or the fact that a node is participating into the quorum, and some other settings for your production architecture can be changed online that way. We even include a facility to mark a node as ongoing maintenance, so that pgauto failover knows that this node is not a secondary anymore. You cannot failover to a node that is currently in maintenance. pgauto failover finally also includes network split detection and protection. Protection against split brain. So the last thing you want is to have two primary nodes at the same time online. You want one primary, whatever happens, and sometimes you might have zero, but one is okay. Zero is temporary, it's transient, and it's not a happy case. But more than one, it's the end of the world, because now you have to reconcile data that have been modified concurrently on different nodes, and that's very complex. We implement in pgauto failover, we include active monitoring and role changes. We intend that the role of a node is dynamic. And you can also do it manually. You can perform a failover or perform a switchover within a single command line very easily on your system, and you can even go as far as choosing which node is going to be promoted, because we implement both pg rewind and also fast forward thanks to cascading replication. So you can choose which node is going to be the next primary if you need to. For example, when you move from one AZ to another, you can just failover to the node in the new AZ. That's included in pgauto failover. What is not included yet in pgauto failover is the implementation of an archiving and disaster recovery solution, wherein when there is a failover that happens, you have the guarantee that you don't need to change the setup of the archiving solution. And also we check and verify that every wall bits that we have is the right one. We didn't lose any during the failover. And if a BAS backup, for example, was happening during the failover, we can redo it, because it's not worth anything now. This is not included, as far as I know, in most of the classic solutions for Postgres. All of them in the documentation are telling you how to set up archiving in a static way. They don't tell you what you need to do when the primary changes. So that's why I think pgauto failover needs to implement that. Also, we would like to implement configuration management, tracking, and extension management, and some more in a way that makes sense, so that you can failover at any time with strong guarantees that you remain available both at the service level and at the data level. And that's it for my presentation about PostgreSQL architectures in production. And now it's time for asking me questions. Ask me 2 questions.